Hello children, welcome back to the session 2 of real numbers. In the previous session, we learned about real numbers, the classification of real numbers into rational numbers and irrational numbers, and we have seen the families of each. So any number which can be written in the form of p by q is a rational number, and the numbers which cannot be written in p by q form are irrational numbers. So that was in the first session. Now in the second session, before I begin, let me tell you the deleted portion from this chapter. So from this chapter, Euclid's division algorithm is deleted for this year. So exercise 1.1 is completely based on Euclid's division algorithm. So this has to be deleted. We are not going to do this exercise 1.1. The next exercise is based on fundamental theorem of arithmetic. So today's concept is the concept of fundamental theorem of arithmetic. So let's see what is this theorem. So before we go for this theorem, let us recall prime numbers. Like 2. 2 is a prime number. What are the factors of 2? Factors of 2 are 2 and 1 only. Yeah. Then what are the factors of 3? The factors of 3 are 3 1 times. 3 into 1 3. Or if I take another prime number like 31, what are the factors of 31? 31 goes in 31 table. The 31 1 times is 31. So prime numbers, these are all prime numbers. So prime numbers have 1 and itself as a factor. Okay, the numbers which have 1 and itself as a factor, like here the factors of 31 are 1 and 31, the factors of 2 are 1 and 2 itself. Okay, so this type of numbers are called prime numbers. Then the numbers which has more than 2 factors. Okay, the numbers which has only 2 factors are prime. Okay, there are infinite prime numbers. Okay, then the numbers which has more than 2 factors are called composite numbers. So this fundamental theorem is for composite numbers. So what are composite numbers? Let's take one simple example of a composite number like 24. 24 is a composite number because the factors of 24 goes like this: 2 12 times. Okay, and this goes in other tables. Okay, 3 8s are 24. Okay, 4 6 are 24. Fine. So this composite numbers, we can find the factors using a tree diagram. This you have done in your previous lower classes. 2 6 times, 6 can be splitted as 2 3 times. So these are the factors of 24. So factors of 24 are these all: 2 2 2 and this 3. So 24 can be written as the product of 2 into 2 into 2 into 3. So 2 2s are 4, 4 2s are 8, 8 3s are 24. Okay, so now coming back to the fundamental theorem of arithmetic, this theorem says that every composite number, I took one example of 24, like this every composite number can be expressed or factorized as a product of primes. So every composite number can be written as the product of primes, like I have written for 24, and this factorization is unique, isn't it? Whoever finds the factors, prime factors of 24, they get the same factors. Whichever method you apply, that doesn't matter. You can even find the factors by this method 24. You can find the factors by division method also. 2 12 times, 2 6 times, okay, then 2 3 times, yes, 3 1 time. So factors of 24 are 2 power 3 and into 3. So either you find in the division method or you find by using tree diagram, the factors are same. So the product of, and this factorization is unique apart from the order in which the prime factors occur. Okay, so let's go through it again. Every composite number can be expressed as product of primes, clear? And this factorization is unique apart from the order in which the prime factors occur. So here I can write this as 2 cube into 3, or I can write it as 3 into 2 cube. That doesn't matter. The order of factors doesn't matter apart from the order in which the prime factors exist. So both are correct, but usually we prefer the least number in the beginning. There is nothing wrong in taking large number in the beginning. Okay, so we must always use prime numbers here. That is very important because this is prime factorization. Okay, so we are going to continue with this concept in exercise 1.2. Express each number as product of its prime factors. So 140, the first question I have taken here, 140 270 times, then 235 times, then 5 7 times, 7 1 times. So you can observe these all are prime numbers, isn't it? I cannot write 140, okay, and I cannot divide it by 14 10 times. That will be wrong because 14 is not a prime number. So you should not take composite numbers here. Okay, you should always take prime numbers. Prime numbers like 2 3 5 7 11 13 17, so on. Okay, so the factors of 140 are 2 into 2 into 5 into 7, or you can write it as 2 square into 5 into 7. These are the simple problems which you did in your lower classes also. Okay, but here you have it again in 10th class. Very simple exercise, very simple chapter if you concentrate, that's all. We are going to learn few new concepts in this in the upcoming sessions. Next, 156 is also done in the same way. The factors of 156 are here. For your reference I have given all the bits here. Okay, 3825, 5005. Okay, so keep it in mind, you must take prime numbers only. Okay, then I have given you some questions here to try. Okay, try these questions, find the prime factors of this all and send it to me. And what are the prime numbers? Just for your reference I am giving you the primes. You should begin with 2 2 3 5 7, then comes 11 13 17 19. Okay, then 23 29. You learn about the prime numbers from 1 to 100 in 9th class. Okay, so make sure you use these numbers when you are solving these questions. Thank you everyone, and all the best for your next test. Thank you.